Let's say you're playing dually. You find Ignition Core day 1, you're very happy because you're gonna get 10 wins no matter how you play, but you still want to optimize decisions like what to put cinders on between the core and soldering gun. Or is it better to take the cooldown reduction of your Ignition Core or the cooldown reduction of all your burn items if you only want to maximize your burn damage per second? Here, for example, I might be interested in knowing if I'm stacking burn to know if I can take on the strongest PvE encounter. And stacking burn also has to do with precise cooldowns because you lose 2 burns per second, so you essentially stack burn if your amount of burn per second damage is higher than 2. To answer these questions rigorously, it is very important to know the effective cooldown of your core, which is the amount of times it effectively procs, knowing that it gets charged by items to its left. So its cooldown is definitely not the amount which is written on itself. It also depends on the cooldowns of your other items. Let's assume you have a 6-second cooldown core and a 1-second cooldown item to its left. Every 1 second, what's happening is the core charges for 1 second and the item charges the core for 1 second. So every 1 second, that's 2 seconds of charges for the core. It's as if we said that the core had an effective cooldown which is equals to its base cooldown divided by the 2 seconds of charges every 1 second. So that's 3 seconds of cooldown. Now, if we change the 1 second cooldown item by a 2 seconds cooldown item, we can say that every 2 seconds the item charges the core 1 second, but that's the same as saying that every 1 second the item charges the core 0.5 seconds instead. So the effective cooldown of the core is 6 divided by 1.5, which is 4 seconds. Now, how does this generalize if you have many items to the left of the core? Let's say with cooldown CD1, CD2, CDN. So every 1 second the core still charges itself for 1 second. Now item 1 charges the core for 1 divided by its cooldown. Just like we said, item 1 charges for 1, item 2 charges for 1 divided by 2, which was 0.5. So in general, the item charges for 1 divided by its cooldown. Same for item 2. And up until item M. So what I'm gonna call the discounted factor is gonna be the sum of all these charges in 1 second. So that's 1 for the core, 1 divided by the cooldown of 1 for the item 1, the same for item 2, up until 1 divided by the last cooldown. And the effective cooldown of the core is just its base cooldown, which is 6 here, but it could obviously be any cooldown, divided by this discounted factor. This is a very useful tool that a friend of mine made based on the previous calculations to compute the effective cooldown of your core based on the item to the left. In my previous example, I had a 6-second cooldown ignition core, and to the left I had an Uzi, a first Aiden, and LEDs, so that makes the effective cooldown of my core 2.88 seconds. Also, the previous formula generalizes pretty well for items with different cooldowns reduction based on charge than 1 second. For example, a bomb squad which charges 2 seconds on adjacent friends. If it is only adjacent to 1 Aiden, this effective cooldown will be 3.6. And in order to generalize the formula, you just have to replace the 1 divided by the cooldowns by the amount of charges divided by the cooldowns. So here for first Aiden, in 1 second it charges 2 divided by 3. If we go back to the example, the effective cooldown of the core is 2.88 seconds. Let's round to 3 seconds for easier calculations. It has 9 burns, so that's 3 burns per second, minus the 2 burns that get used every second. It means I stack 1 burn per second. This would not be the case if the core was still bronze, because then it will have 6 burns divided by 3 equal 2 burns per second, which is the limit where it doesn't stack, so my damage would not increase over time, and I definitely would not be able to beat Rogue Scrapper. You might argue that I still stack a little burn because the real cooldown is lower than 3, but the calculation doesn't take into account the internal cooldown of the charge mechanic, which is not instantaneous, and also the fact that you cannot overcharge, meaning that if you charge at 5.5 seconds, you will start the next cycle at 0 and not at 0.5 seconds. So you should often overestimate the cooldown. Finally, I'm definitely not taking into account the slow or haste effects because they are mostly random in their targets. For your homework, you can try to compute the effective cooldown of the core in this board using the tool I mentioned earlier, which I'm going to put in the description of the video, as well as the text description for all the items from the left to the right. This situation is a little bit more complex than the previous one because there are 2 items with charge mechanics, so you have to proceed in the right order. If you get the right answer, you can put it below and I'm gonna reward you with a diamond running bow for only 20% of your max health.